Hello everyone, so in this video I'll be showing you how to tackle this family of function question which Vika loves to throw at students, and most of the Victorian students often trip on this, so I thought I just might quickly go over briefly to help you out. Alright, so a question says that we are given this function where k is a variable and that variable falls under a subset of I, which is all real numbers, and we have to find the values of k such that f of x has 1 solutions, 2 solutions and 3 solutions. Now 1 solution can also mean 1 x-intercept, 2 solution can mean 2 x-intercept, and so on. Alright, so what's our very first step when we are solving for x-intercept of any function? Well, we set y equals to 0, so I'm just going to do that. Just write the equation down, 3x cubed minus 4x squared minus 12x plus k is equals to 0. Now, next step I'm going to do is move the k onto the other side. Oops, I meant to write 3x cubed minus 4x minus 12x equals to minus k. Now why did I do that? Also, what did I do first in the first place? Well, I just split this function, this one entire function, into two different functions. One of them is this and the other one is this. I'm going to call this function g of x, and I'm going to call this function h of x. Now why did I do all that? Just bear with me. I'm going to draw the graph to explain. So just give me 1 minute. I'll just quickly draw the graph. Alright, so this is our graph for h of x and g of x. Now g of x is equal to minus k. Now this minus k can mean that it's just a horizontal flat line, and this k value can move this graph up and down, translate this graph up and down depending on the value of k. Alright, say that our graph is here. Now why did I do that? I'm going to explain you that. So say that this is the position of our two graphs, right? Now we can see that these 3 points over here, 1, 2 and 3, they all share the same y coordinate, the same y value, am I right? And that same y value also corresponds to negative k. So we can see a direct connection. So this entire question just comes down to finding the values of y for which these two graphs intersect once, twice and thrice. That's really it, because there is a direct connection of y values and negative k. I hope that made sense. Alright, I'm going to proceed now. So now that we know that, where do we start? Do we find 2 solutions first? Do we find 1 solution first? Or do we find 3 solutions first? Well, the ideal choice would be to find 2 solutions, the k value or the y values for which these two graphs intersect twice. Now why is that? Once we know the value of this y value, which we can easily find out because, well, this y value occurs at the turning point over here and here, which we can easily find out because we know our h of x function, so we can easily differentiate, set it equal to 0, find the x coordinate, substitute it back in to find y. After we know what the y value is here at these 2 points, well, we can simply just say if y value is bigger than this particular value over here, then it will only have 1 solution. So if I were to move this graph up more, like a bit more than this particular y value, well, you can only see that it has 1 solution. Similar here, if I move this y value, if I move this line down, if I move y value a bit down further, then this other turning point, well, we can see again there's only 1 solution. So, and similar for 3 solution. 3 solutions occur when it's between these two y values, right? And that's why I'm going to find the y values or the k values for which there is only 2 solutions. So let's get into that. So we have a function here, h of x, which is equals to 3x cubed minus 4x squared minus 12x. Now to find this stationary point here, the x value of this stationary point, what we will do is we will take the derivative, which is h dash of x, and set it equals to 0. Why do we do that? Well, because if I were to draw a tangent line over here, a tangent line right over here, we can clearly see a tangent line that passes through the turning point. We can clearly see that this tangent line is completely flat, meaning it has no gradient or a gradient of 0. So when the graph of hx has a gradient of 0, that means it's also a turning point or a stationary point. So let's derive it real quick. So h dash of x would be equals to 9x squared minus 8x minus 12. Now we'll set this equals to 0 equals to 0. Now solving it on CAS, you can easily solve it by pressing menu 3 once, then the solve function will appear, type the equation in, and you'll get this answer, which is x is equals to minus 2 square root of 31 minus 2 and over 9, and x is equals to 2 times square root of 31 plus 2 over 9. Okay, so what does this value on this graph mean? So where are these two values? Well, what we just calculated was this coordinate, this x coordinate over here. So I'm just going to call this point A and point B just to make our lives more easier. So point A would equals to negative 2 multiplied by the whole root 31 minus 2 over 9, because that's the x coordinate. So x coordinate over here is just this value right over here, this one. Now if I were to find the y coordinate, what we'll do, well, we'll substitute this x coordinate back into h of x. So h of x, well, sorry, h of the whole thing, 2 times root 31 minus 2 over 9, and that would simplify the answer. Again, I did this on my CAS calculator, which would be 496 square root of 31 over 243 minus 1424 over 243. So that's our coordinate A, which is 496 square root, 499, good, 496 square root of 31 over 243 minus 1424 over 243. So that's our coordinate A, done and dusted. Now let's find our coordinate B. Same technique, we'll again substitute this point right here, because this one was for A and this one is for B. So I'm going to substitute this x coordinate right over there. So 2 square root of 31 plus 2 over 9, and which will give me, again, I did this all on CAS, I'm not a super genius who can evaluate this in my head, square of 31, 243 minus 1424 over 243. So this is our point B, which is equals to 2 times square root of 31 plus 2 over 9, comma, minus 496 31 over 243 minus 1424 over 243. Alright, now I'm going to visually represent this on the graph, so I'm just going to copy this graph down. So we can clearly see that when y value is equals to either of these two values, one here or this one, or this one, there's only two solutions. So what we can do is, well, we are not solving exactly for y values, but what we are solving for is minus k, which is also y. Because as you can see, that y value here, y1 is equals to minus k, and y2 is equals to minus k. So we have both of our y values, so I'm going to substitute that in, k, which is equals to, which will result in k being, which implies that k is 1424 over 243 minus 496 square root of 31 over 243, or negative k equals to, which implies that k equals to for the whole thing but positive. So alright, so these are the k values for two solutions. K equals to, so these are the k values for which there are only two solutions. It makes perfect sense because as you can see here, these two graphs intersect twice at this particular y value, and y equals to minus k. Alright, now what should I do when I'm finding the k values for just one solution? Well, that's going to be an easy one now, because for one solution, well, we can see that if I were to move this line above this point, there is only one solution, and if I were to move this line below this point, below point B, there is another solution. There is only one solution as well. So as long as I keep the k value, so as long as minus k belongs to all the way to infinity. Now, why have I not put square bracket here? This is a round one. Why have I not put that? Well, because if I include that, if I include this value by putting in a square bracket, that would result in two solutions, and we are only finding for one solution, so we put parentheses and not a square bracket. Now, if I were to drag this line all the way up to infinity, well, we still have only one solution, and that's why we have infinity over here. Okay, and there's also another solution, which is minus k belongs to any value below this y value, so any value below the y coordinate of point B, right? So let's find that one out. So we can say that k belongs to, now we are finding, these are the solutions for k values, not k values, negative k values. But what we are asked to do is to find the solution for k, not negative k. So how do I make this negative k just disappear to just being k? Well, pretty simple. We can just multiply this whole thing by -1. And when we do that, the domain also flips. What I mean, I'll show you. So, if I were to write this in terms of just k and not negative k, this positive infinity will become negative infinity, and this term will become 1424 over 243. I'm just switching the sign up, minus 496 square root of 31 over 243. Including, instead of writing negative infinity, it will go all the way to positive infinity. But obviously, we have to write it from the smallest value to the largest value. So a small value here would be 496 and not infinity. 496 square root 31 over 243 minus 1424 over 243 all the way to infinity. And for three solutions, well, again, for three solutions, we can see that this graph over here intersects with h of x 3 times when it's between this y value and this y value. Any value between, well, we can see there are three solutions. So we can say that negative k is between, and that's the values for three solution. But again, we are looking for we are not looking for minus k, we are looking for just k. So what we'll do is, again, we'll switch the domain up. So k belongs to, and that's it. That's how you tackle these sort of questions. I hope it made sense. If it didn't make sense at any point, because I do understand this concept is tricky, please let me know down in the comments, and I'm happy to clarify any of your doubts. Thank you for watching, and I'll see you in the next video.